Good morning, all of you. Today we are going to see ideal solution and non-ideal solution. A solution which obeys Rawls' law is called ideal solution. A solution which does not obey Rawls' law is non-ideal solution. Let's see these things. A solution which obeys Rawls' law over the entire range of concentration is known as ideal solution. Now, for that, delta delta V mix means after mixing, there should not be any change in volume. Similarly, delta H mix after mixing or during mixing, no heat will be evolved or no heat will be absorbed. When does heat evolve? When a chemical reaction takes place. When does heat absorb? During a chemical reaction. That means no chemical reaction should take place. So these are the two conditions. Delta V mix is equal to 0. What is meant by this delta V mix? Suppose I have taken a solution here. Another solution I have taken. I mixed these both. So the concentration, the volume, the total volume, this plus this, that is this much volume. That is V1 plus V2. V1 I have taken, V2 I have taken. After mixing, I should get V1 plus V2 only, not more than this, not less than this. Suppose I am taking 5 ml of this and 10 ml of this. I should get 15 ml only. This total volume after mixing, it should not go to 16 ml or it should not go to 14 ml. Not more than this, not less than this. So maximum means the volume, it should be V1 plus V2. Means delta V mix. After mixing, there should not be any change in volume. There should not be any change in volume. That is what is meant by delta V mix. Now, what is delta H mix? Delta H mix means during mixing or after mixing, there should not be any heat change. No heat should be absorbed, no heat should be evolved. What happens when delta H is negative? When delta H of mixing is negative, suppose if it is negative, last year we learned negative means heat energy is evolved or liberated. Heat energy is liberated. So it is an exothermic reaction. It is an exothermic reaction. Such delta H negative should not be there. Similarly, delta H positive also should not develop. If delta H is negative, we say this is not ideal solution. It is deviating from ideal solution. That means non-ideal solution. So it shows negative deviation. We say it shows negative deviation. If delta H is negative, the solution is showing negative deviation. A solution is showing negative deviation means during mixing they are reacting and some heat energy is liberated. Some heat energy is evolved. Now, what about delta H mix? Delta H mix, if it is positive, what about delta H mix positive? If delta H mix is positive, that means heat energy is absorbed. This also we learn when heat energy is absorbed, we say positive, delta H positive. Now we say if delta H is positive, the mixture shows positive deviation. Positive deviation from ideal nature, from this ideal situation. A solution which does not obey Rolle's law is known as a non-ideal solution. The question may come, define non-ideal solution. Simple. One more question. A solution which does not obey Rolle's law. What is Rolle's law? P is equal to P naught AXA, PB is equal to P naught BXB. In this case, vapor pressure is either higher in the case of non-ideal solution. In the case of non-ideal solution, that is when the delta H mix is positive or when the delta H mix is negative, means in this case, vapor pressure is either higher or lower after mixing. So in the case of non-ideal solution, means when delta H is positive or delta H is negative. During this mixing, when this delta H is positive or when the delta H is negative, vapor pressure is either higher or lower. Now we are moving to vapor pressure higher, vapor pressure lower. If it is positive deviation, vapor pressure is higher. Vapor pressure is higher. Vapor pressure of this mix is higher. If it is negative deviation, vapor pressure of this mix is lower. So you can imagine if the vapor pressure is higher, what happens to the boiling point? If vapor pressure is higher, what happens to the boiling point? Vapor pressure is already higher. Now you have to heat only a less to match it with atmospheric pressure. Boiling point is the temperature at which the vapor pressure of this solution becomes equal to the atmospheric pressure. So now vapor pressure is already higher than the expected. Vapor pressure is already higher. In that case, it will easily match with this atmospheric pressure. So the boiling point will be less. It will boil at a lower temperature. So now we are moving to positive deviation. Positive deviation means when the vapor pressure is higher. So for that, the typical example I am going to take is ethanol and acetone. There are other examples also. Ethanol. I am taking ethanol. In this ethanol, what is ethanol? Ethanol is CH, CH3, CH2OH. This is ethanol. I'll write it as C2H5OH ethanol. Between ethanol molecules, so there are so many ethanol molecules. We know that between ethanol molecules, hydrogen bonds are existing between ethanol molecules in this way, that is ROH, then hydrogen bond, HOR, then hydrogen bonds, HOR. So hydrogen bonds are existing between this ethanol molecule. Now to this we are adding acetone. To this we are adding acetone. So there are hydrogen bonds between ethanol molecules. This ethanol, I am marking it as A. So there are AA interaction. AA interaction means the interaction between ethanol and ethanol. Now there are interaction between acetone and acetone. So there are interaction between acetone and acetone. We call it as BB interaction. BB interaction. Now, when this acetone is added to ethanol, when this acetone is added to ethanol, acetone molecule get in between, acetone molecules get in between ethanol. That means ethanol molecules are now free. They can come to this vapor state easily. They can come to the vapor state easily. Now what happens? Vapor pressure increases. Ethanols, there are interaction between, previously there were interaction between AA molecules. There were interaction between BB molecules. When acetone is added to this ethanol, now ethanol molecules are free. Acetone molecules come in between ethanol molecules and the hydrogen bonds are broken. Ethanol molecules are free. Ethanol molecules can come up. Ethanol molecules can come up. Acetone molecules will also be coming up. So vapor pressure of this mixture increasing. When vapor pressure of the mixture increasing, what happens to the boiling point? I'll show the vapor pressure, increased vapor pressure. So it was before P naught A, P naught A, and here P naught B. This is xa is equal to 1, xb is equal to 0. That side xb is equal to 1, xa is equal to 0. Now P total is equal to Pa plus Pb. Now vapor pressure of ethanol is increasing. Vapor pressure of ethanol is increasing. Vapor pressure of acetone is also increasing. and vapor pressure of the mixture, so vapor pressure of mixture is also increasing. This is the graph for positive deviation. Since the vapor pressure is high, the boiling point, when since the vapor pressure is high, what happens to the boiling point? Boiling point is low. The liquid mixture will boil at a lower temperature. Another example is that ch2 and acetone. ch2 and acetone. So alcohol, if one component is alcohol, it is positive deviation. If one component is alcohol, ethanol, propanol, because alcohol there exist hydrogen bonds. When the other components come in between, these molecules are free. Alcohol molecules are free. They can easily go to the vapor state. So the vapor pressure is increasing. You think that if one component is ethanol, alcohol, then it will be positive deviation. Okay, 99 percentage it will be positive deviation. Now next we are moving to negative deviation. Here the typical example is chloroform and acetone, that is CHCl3 plus acetone. CH3 C double bond O CH3. This is acetone. Chloroform. Chloroform CH Cl Cl Cl. This will be making hydrogen bonds with acetone. Now you see, there was no hydrogen bonds between chloroform molecules. Not much hydrogen bonding between acetone molecule. Acetones are ketones. Ketones, no hydrogen bondings. Aldehydes, in smaller aldehydes, there will be hydrogen bonding. But here, there's no hydrogen bonding in chloroform, no hydrogen bonding between this acetone molecules. But when they are mixed, new hydrogen bonds are formed. This is new hydrogen bond, new H bonds. So what happens? This is A, this is B. There was no interaction between AA molecule, not much interaction between BB molecules. So AA interaction, BB interaction. Look at AB interaction. AB interaction is more stronger than AA interaction or BB interaction. So in such cases, neither chloroform can go nor acetone can go. So vapor pressure, since they are locked, vapor pressure decreases. Expected vapor pressure will not be there. It is better if as chloroform alone or acetone alone, chloroform can go up, acetone can go up, but when they are mixed, both cannot go to the vapor state. That is, AB interactions are more stronger than AA interaction or BB interaction. What happens to this vapor pressure? Vapor pressure will be decreasing. So vapor pressure decreases means boiling point increases. So the graph that is P naught A, P naught B, X is equal to 1, xb is equal to 0, x is equal to 0, xb is equal to 1, so negative deviation means it is less, P total is less, PA is less, PB is less. This is P total. P total is equal to PA plus PB. So, vapor pressure is lower. Vapor pressure is lower means this is vapor pressure, this is mole fraction. Mole fraction. Vapor pressure is less means you have to heat more and more. Escaping tendency of both decreases. Vapor pressure is low, so boiling point will be high. Vapor pressure is low, boiling point is high. So, typical example for negative deviation is a mixture of chloroform and acetone. Typical example of positive deviation is ethanol and acetone. In both, we are keeping acetone so that you can remember it easily. Next and the last topic is azeotrope. Azeotrope. That is, meaning is the constant boiling mixture. Constant boiling mixture. In junior classes, we learned when we heat a mixture of ethanol and water. When we heat a mixture of ethanol and water, suppose a round bottom flask is taken and if we take a mixture of ethanol and water, if we take a mixture of ethanol and water, and if you are heating it, if you are heating or boiling, what will happen? Ethanol having 78 degree Celsius boiling point will be coming out. Water boiling point is 100 degrees Celsius. So this is of ethanol and this is of water. So first ethanol will be coming from this mixture. On cooling, you can put a Liebig's condenser here. On cooling, water can be passed outside this tube. Water can be passed outside this tube and you can cool that vapors and you can get ethanol first. You can get ethanol first. On heating, first at you're heating from the room temperature, for example 35 degrees Celsius, 45, 55, 70, 80, like that the temperature will be increasing. But when the temperature reaches 78 degrees Celsius, ethanol will be coming up first. Then after the removal of ethanol, what will be remaining? What will be remaining in this? Only water. Only water. So you can separate this. But if the mixture is having a particular composition, for example 95 percentage ethanol, 95 percentage ethanol means 5% water. When the composition comes to this 95% ethanol, now what happens? On heating, on boiling, both will be coming up. Both will be coming up just like a solvent, just like a pure solvent. So separation will not be possible. If it is 95 percentage ethanol by volume, if it is 95 percentage of ethanol by volume, what happens? Both this ethanol I am putting, so both will be coming up. Separation is not possible here. Just like just like a pure solvent, it distills over. So such mixtures are called azeotrope, a binary mixture that cannot be separated by fractional distillation. A binary mixture that cannot be separated by fractional distillation due to the same composition in the liquid and vapor phase. Due to the same composition in the liquid and vapor phase are called azeotropes. This happens at a particular composition. Here it is 95 percentage ethanol by mass. So in the liquid phase, same composition, vapor phase also same composition. So in that case, Means both will be coming. In that case, separation of these mixtures, separation of these components from this mixture is not possible. So such mixtures are called azeotrope. Binary mixture that cannot be separated by fractional distillation due to the same composition in liquid phase as well as in the vapor phase. Such mixtures are called azeotrope. This happens at a particular composition, for example 95% ethanol by volume. Now, here also minimum boiling and maximum boiling. Minimum boiling means minimum boiling point. The solution which shows large positive deviation from Raoult's law form minimum boiling azeotrope. So the next heading is number 1, that is minimum boiling azeotrope. Minimum boiling azeotrope. Azeotrope means the solution which is having large positive deviation. Positive deviation. Positive, so if the deviation is positive, boiling point will be less. That's why we are calling minimum boiling azeotrope. The example is the same example you can give, that is 95% ethanol by volume. Ethanol by volume. Number 2, maximum boiling azeotrope. Maximum boiling azeotrope. A solution which show large negative deviation from Raoult's law form maximum boiling azeotrope at a specific composition. Opposite to this, that is, the solutions which show large negative deviation. Large negative deviation. What happens if the vapor pressure is lower? If the vapor pressure is lower, boiling point will be high. So we say maximum boiling azeotrope at a specific composition. Example 68% the CO2 by heart, 68% nitric acid. Nitric acid by mass. This is by mass, the previous one is by volume. So this is maximum boiling azeotrope. Solutions which show large negative deviation from Raoult's law form maximum boiling azeotrope at a specific composition. Example is 68% nitric acid by mass. Thank you. With that, we stop this chapter. We finish this chapter. Thank you, all of you.